Hey guys, today we're going to look at our final distribution, the hypergeometric distribution. So this distribution differs from the ones we've looked at previously because the trials are dependent. So each trial will affect the future trials. It is still a success or failure though. So the first question we've got here is a jury selection. So we're choosing a jury of 6 members. Okay, so this is a civil trial, 6 members, and we're drawing from a pool of 8 citizens, 8 of whom are men, 10 of whom are women. So we're going to look at the probability distribution for the number of women on a civil or on this jury. So the reason this is different from our previous distributions is that if I pick a woman, then that is going to decrease my chances of drawing a woman the next time. And so if I draw 3 women, that has greatly decreased my chances because the number of men has stayed the same and the number of women has decreased. So this is not, so these are dependent trials. Depending what happens the first trial will affect the second trial. So we're actually going to go down. I'm just going to jump straight to the actual formula before we start. This is not a formula you would necessarily figure out on your own. So what it is we're going to have A choose X times N minus A choose R minus X. And the whole thing is divided by N choose R. So that is where A is the number of items in the group the question is interested in. The number of items in the group the question I'm running out of room here. Oh, there we go. Okay. So the number of groups or items in the group the question is interested in. So, for example, this question we're looking at now with the jury, that would be the number of women. Okay. N would be the total number of items. Okay. Let's see. R is the number of items being selected. And finally, X is the random variable. Whoops, I can't spell random. Okay, so that is our probability formula. So we're going to go through, we're going to go up to this one. So for this question here, our A value is going to equal 10. Okay, and that's because there's 10 women. Okay, and the reason we know it's the women, the number of women, is because this is, we're finding the distribution for the number of women. Okay, so that's why that's where that's going to come from. It's what we're interested in. N is equal to 18 because there's 18 total people, and R is equal to 6 because it is a 6-person jury. 6-person jury. Okay. All right. So our X is obviously this variable. We're going to go through all the various X's. Okay. So let's just start plugging them in. So we start with 10, choose 0, times, times 8 choose 6 over n choose r would be 18 choose 6. Okay, and so that equals 0.0015. All right, so then we move on. The 10 stays the same, but now we've got choose 1 times 8 choose 5. You'll notice that this number and this number will add up to your n value. This number and this number will add up to your r value. Okay? And then on the bottom we'll have 18 choose 6. Okay, and so that's going to give us 0.03. All right. 10 choose 2 times 8 choose 4. Still over 18 choose 6. The bottom shouldn't change as you go. It should stay the same. We'll get 0.17. We'll have 10 choose. Whoops, that's an 18. Oh. 10 choose 3 times 8 choose 3 over 18 choose 6 is equal to 0.36. Uh, 10 choose, whoops, not 2. Gonna be choose 4 times 8 choose, that was a big 8 I drew there, well, 18 choose 6, which will give us 0.32. 10 choose 5 times 8 choose 1 over 18 choose 6, which will give us 0.11. And finally 10 choose 6. What happens? I don't know what I just did. Hold on. Oh, there we go. All right. I have no idea what just happened there. All right. Anyway, sorry. 10 choose 6 times 8 choose 0 over the 18 choose 6, which will equal 0.011. Okay. So there we go. If we're to graph this, we'd have 0.1, 0.2, 0.3, 0.4, and then we'd have 0, 1, 2, 3, 4, 5, 6. Okay, and it would look kind of like this. We'd have something like that. A little bit bigger, then we go up to about here, and then we go up, way up to here, and down here, and then down here. Oh no, I don't like that last one. That should be lower, and down there. So if we were to graph it, this is kind of what it would look like. There you go. So that is our probability distribution. So the next question, as usual, is what is the expected number or the expected value? So again, I'm just going to jump down. I'm just going to tell you the formula here because this one's not necessarily obvious. So you're going to do R times A divided by N. Okay? So it's a fairly simple one compared to that probability formula anyway. So we will have E of X is equal to R times A over N. I know you're not supposed to do equal signs side by side, but I did not leave myself any room. over 18, which equals 3.33. Okay, so there you go. So you expect 3 1/3 women to be on the jury, which of course does not make any sense, but that is quite all right. Okay, so that's that. So let's do another one. Well, I'm actually just going to skim through this next one because it's basically the exact same. So 5 cards are randomly dealt from a standard deck. Show the probability distribution for the number of cards dealt that are 10 or less if aces are high. What is the expected number of cards which are 10 or less? So the first thing here that we need to do is we need to go through, and I'm not actually going to do the whole distribution here. I'm just going to go through and we are going to look at the A, the N, and the R, because as long as you know which formula to use and you can identify the variables, this is fairly straightforward. So A is the number of cards that are 10 or less. And so there's actually 36 cards that are 10 or less. Okay. And then we go N. Well, N is the number of cards in this case, so that would be 52. So that's the number of cards. And finally, R is how many we're taking, so that would be 5. Okay, so we're selecting 5 cards. It is worth mentioning that the reason this one is a hypergeometric distribution is that I'm not replacing my cards here. I'm pulling cards out of the deck. Once I pulled a card out of the deck, I've changed the chances. There's less cards, there's less successes. Okay, every time you pull a card out, it changes what's in the deck. So this is why this is hypergeometric. So we can fairly quickly throw in the expected value here. So we'll have R times A over N, which is 5 times 36 over 52, which is just equal to 3.46. So we expect there to be 3.46 cards that are 10 or less. All right, and so I'll let you do the actual probabilities on your own because I don't feel like doing that right now. So let's jump ahead to a question that's a little different here. So marbles, we've got a bag that contains 2 red, 5 black, and 4 green marbles. 4 marbles are selected at random. Now this is without replacement. This is good. This right here, the without replacement part. Without replacement. That is a very big hint that this is going to be a hypergeometric question. Now, obviously, today, everything's going to be a hypergeometric question because that's what we're learning. But down the line, that will be very helpful to realize that without replacement is going to make it dependent, which means it's going to be hypergeometric. Okay? So, for this question, let's just go through. And you always want to start this way. You want to say, well, what's my N? So, in this case, it would be 11. What's my A? In this case, it would be 5 because I'm looking at black marbles here, right? I didn't read the question out loud, but that's what it is. Black marbles. Now, we got to be careful there because as I move forward, that number will actually change. And in this case, R is 4. Okay? Because I'm saying what is the probability that all 4 are black. So I'm drawing 4. There's 5 black ones. There's 11 total. And so I just do the probability of getting 4, which is going to be 5 choose 4 times 6 choose 0 divided by 11 choose 4. And again, make sure you're actually putting these in your calculator and getting the right answers. It should work out to 1 over 66. Okay, I mean it's 5 over 330, but I'll reduce it. All right, so where you got to be careful now is as I jump ahead to this next question, what's the probability that exactly 2 are green? Now, what I've done here is I've actually changed what the A value is. So I still have N equal to 11. That hasn't changed. There's still the same number of marbles. R is still equal to 4 because I'm still drawing 4 marbles, but my A value has changed because I'm focusing on a different group. So A is now 4 because we're looking at green marbles. and there are only 4 green marbles. Okay? But from there, I want to know what's the probability of 2. So I'm going to have 4 choose 2 times 7 choose 2 over 11 choose 4. Okay? And so that's going to give us 126 over 330. Okay? Which reduces to 21 over 55. Okay? And that's my final answer. All right, so what's the probability that exactly 2 are green and none are red? So this is where we're going to get into a little bit more tricky stuff. So I'm still going to use my n value as 11. I'm still going to have my r value as 4. Okay. Now I'm focusing on green again, so I'm going to leave the a as 4 again. But I'm going to do something a little tricky, and you're going to have to think about the formula a little bit harder than before. So here, I'm going to do it over here just so I have more room. I'm going to say I want the probability of 2 again. And I would have 4 choose 2, because this is me picking the green marbles. There's four green marbles, I'm picking the 2. Where it's going to be more difficult is this second part. If you noticed, I always said, well, this next number was we were choosing from all the ones that were not green. So I'm still picking 2 marbles that are not green, but I'm going to subtract 2. Instead of having them add up to 11, I'm going to have them add up. Actually, let me use a blue here. Okay. Okay, so that we're going to say, well, there's no red. So we'll subtract 2 from that. Okay? Because we're choosing from the 5 remaining that are not red, because there were 2 red marbles. Okay? So that's what you have to do there. And I mean, that's not incredibly obvious, but as you do more and more of these questions, you'll kind of get the hang of that. So, and then the bottom is still going to be 11 choose 4. Okay, so this is going to give us, let's see, 60 over 330. Whoops, 6D, not 6. Which then reduces to 2 over 11. Okay. All right. So then what are the expected values? Now, what's the expected values for all of them? So, well, my expected value formula is just RA over N. So what we'll do is expected of the red. Well, for red, let's see, it would be, the R is still 4. We're taking 4. How many reds are there? There are 2. And divided by 11. So it'll give us 8 out of 11. So I expect 8/11ths. Okay? Expected value for green. Let's see. So we're still taking 4. There's 4 greens out of 11. So we expect 16 out of 11. Okay, and finally, expected value for black. So you can see how, as I change what I'm paying attention to, it's just that A value that's going to change. And so there's 5 blacks. So that gives us 20 out of 11. Okay, and that's it. All right. So, until next time, go Blue Jays.